brief introductions. Myself, my name is Brian Ippolito. I'm the CEO of Orbis Technologies. Orbis is really a global enterprise content management company where we sell software, solutions, applications, analytics. The panel today, we're going to have a lively discussion, I hope, and we've got two experts here that I think will really help energize the audience. We have some great topics to talk about. I'll start, I'll let them introduce themselves and we'll go from there. I'll start with Colonel Kukor. And Colonel, why don't you tell us a little bit about yourself and tell us a little bit about what you're working on?
Sure, so 25 years in the Marines, Marine Intel and Ground Intelligence, and I'm currently assigned to the Office of the Undersecretary of Defense for Intelligence, Pentagon. I work a lot of issues all related to PED, specifically the big E in PED, exploitation. And we, you may have seen the DepSecDef on the 26th of April initiated a project called the Algorithmic Warfare Cross-Functional Team, and I am the program manager for that initiative. And the director is Lieutenant General Jack Shanahan, who is the Deputy Director for Intelligence at USDI. And so I guess our comments today will be mostly focused, because that's what I'm working on, so we'll talk through that.
Perfect. Neil, why don't you tell us a little about yourself?
So, hi, good morning. I'm Neil Wiley. I'm the Director for Analysis at the Defense Intelligence Agency. So my job, writ large, is to ensure the quality, utility, integrity, and probity of the all-source analytic product of the Defense Intelligence Agency, and I'm responsible to Lieutenant General Stewart, the Agency Director, for doing that. I guess I also probably will let you know that by education I'm a classicist. So talking about data integration to a room full of people who are doubtless far brighter on this than I am ranks somewhere between dentists and clowns in my panoply of things that frighten me. So there you go.
Thank you. I have a few topics that I guess we'll start with. First, I love your comment about data quality. One of the observations, if you will, from industry is that we have for a long time really wanted to focus as we do data integration. We really want to improve the data quality, the veracity of the content. So I guess, Colonel, we'll start with you on the end. Give us your thoughts on the importance of data quality and the veracity of the content with what you're working on right now.
Well, I represent the analysts, specifically the military analysts, right? Not necessarily the legions of civilian analysts that are in the intel community. And, you know, I'm a product of the 80s. And I used to play video games at Shakey's Pizza in Manhattan Beach, California. And I would put a quarter in the machine, and the instructions were very simple. Insert quarter and avoid Klingons,
yeah.
Right? So that's the level of sophistication that our analysts need. I think Apple Computer has a phrase, it just works, right? It just comes together. There aren't 10,000 steps. There aren't a million pre-processing steps. It just happens. And in our specific task right now, data quality, of course, is critical, because as we begin this effort to bring machines to analysis, right? As we look at those tasks that are that have patterns that are eminently automatable, right? The quality of the data that's needed for those algorithms to work is frankly the driving element. And as we look at this initiative, we're looking everything from the sensor through data transport, all the hubs and routers and gateways that distort the quality of data. Because at the end of the day, the machine needs to be able to function with the highest resolution data, the highest quality data possible. That's the front end, right, which is once we're getting to something we call inference, which is where the machine is able to detect objects. In this case, this is full motion video, but it could be anything. The quality of that data, and I'm speaking specifically resolution, is critical. But in machine learning, like you will know, there's a key part to this, which is the training of the algorithms, right? These aren't rules-driven algorithms. These are data-trained algorithms. And what we're discovering is we're opening up all new pathways that we had not understood before. The first is the pre-processing of the data before you can even begin to prepare for labeling is quite a task. And we're grateful for all the open source tools that are out there that take large data sets and allow us to quickly screen through it. And we're talking thousands and thousands of hours of data, right? That allow us to sort of look at it all, remove pieces that are irrelevant to the data labeling task, and then we chop it up into lots of bits and pieces, right? 30-second elements so that we can then label. And we'll do this same work, just like we're doing with GeoInt full motion video, we'll do the same thing with text here very quickly. So that pre-processing phase to get the data prepared so that we can put a machine learning algorithm on it is right now being done by analysts by hand. And that the quality of that training data that will be used for 3 functions, right? Training algorithms, testing, and validating algorithms, right? We're going to need 3 large data sets. It's all about the quality and the resolution and then ensuring that it meets standard. Then once we get to inference, which is when we have a functioning algorithm at the edge or wherever, the quality of data coming in has got to be there as well. So it's everything, frankly, to our business.
So, so let me kind of take this up a level or two from my perspective as an all-source analyst. So again, I'm responsible for goodness and all-source analysis across the totality of what the agency does. That's science and technical intelligence, infrastructure analysis, strategic, regional, and military capabilities, transnational, everything. So what matters to me is that we have the ability to have integrity and consistency across the full analytic portfolio. So if you were an analyst 50 years ago, it is entirely possible that you could see, touch, and feel and think about every piece of information available to the United States government that was relevant to your portfolio. It is possible that you will have done that. Now, would you have been able to see, touch, and feel every piece of information in the world that was relevant to your portfolio? Absolutely not. It just meant that you couldn't see most of the information that was relevant to your portfolio. But because you could see, touch, and feel it, we developed an analytic process whereby analysts like to personally pick up, admire, arrange, think about, put down on the table, and pick up another piece of data or information that's relevant, and develop their analysis that way. Well, today that's not possible because there is a ton of data available, and I'm sure you guys have all talked about that, everybody's aware of it. Classified collection systems are far more effective, and that's dwarfed by the amount of publicly available information that the world simply collects on itself now. So under the old analytic method, right, and frankly the analytic method that we frequently still use in a number of circumstances whereby an analyst picks up and arranges and examines, we are looking at an increasingly minute chunk of the information that's relevant to our portfolio. Now that's not acceptable, it's not useful, it's not helpful in gaining insight, and it's not necessary anymore. But to get to the question of data veracity, what that now means is that we have to be able, in some way, shape, or form, to make use of that mountain of data that is now out there that we haven't always used. But we have to understand it to use it properly in an intelligence context, which means it is critical to us, just as with every source we always used to look at, that we understand the capabilities and limitations of each source, we understand where that data is likely to be incomplete, we understand where it's likely to be fragmented, we understand where there is bias, we understand where it is potentially manipulated. We have to understand. And it is hard now to generate the same level of understanding in analytically derived data than it was in source material that was immediately accessible to human. And that's a cultural shift that we have to make over time with the analysts, is so that they become comfortable with analytically derived data. But we have to be very careful about understanding it ourselves before we simply dive into it.
Thank you. So I want to stay on this theme for a second, because when we talk about data integration and we talk about the quality, we have two different perspectives on the quality of the data. But in industry, both commercially and the DoD, there seems to be this push of moving forward in this role of a data scientist, which is hotly talked about, and it's one of the top emerging career fields. So I would really, I'd be interested in your perspective when you talk about understanding the data. So is a data scientist, is that a skill set or is that a position? So we'll start with you, Mr. Wiley.
So, so this is a hot topic, and I think if you ask 100 people out there, you'll probably get 100 slightly different opinions. But since I've got the microphone, you'll have mine. So I think it is a little of both, but it is largely the former. From my perspective in the analytic community, it is largely a skill set rather than a position. And the reason why I say this is, so Colonel Kukor said, the way Apple works, it just works. It's not feasible, possible, or necessary to retrain the analytic workforce to be data scientists. I don't think that, one, it's not possible, and two, I don't think, again, it's not necessary. To me, it's the difference between me and a smartphone, right? So I actually, as technologically ignorant as I am, I can use a smartphone. It enables me to do lots of things that I couldn't do before. Can I build one? No. Can I do all the underlying processing that makes my smartphone useful to me? Absolutely not. But I can use it. It enables me. So in that case, I have smartphone as a skill set. I do not have a smartphone as a position. And I think over time, what we will need to do is develop that skill set in the analytic cadre that makes them more comfortable dealing with quantifiable uncertainty as opposed to subjective uncertainty. So that's really one of the kind of big tradecraft differences in large data, is you have to be used to computational uncertainty. That's not a common skill set with us. And over time, that will happen. But I believe personally that the fundamental qualities that make a good intelligence analyst, grammar, logic, rhetoric, intellectual curiosity, the ability to work well with others in a team, and personal integrity, are the same things that will make a good intelligence analyst everywhere. Julius Caesar's J2, if he was any good, had that. And Buck Rogers' J2, if he or she will be any good, will have that. That's what makes an analyst. The milieu and the technology in which they work will always change. Julius Caesar's J2 probably wasn't very good at air and air defense analysis, but if you grew that same person up in an environment where things flew, he probably would have been. So to me, for the analytic core, it's largely a skill set. I do believe you need some small number of people who actually understand data science, no kidding, at the smartphone build it level, but I think those people will be few, and we'll have to be very careful about what we do with them.
This discussion is just really just shows how early we are in this development of understanding how to use data. And the quick knee-jerk response or whatever is let's just buy a bunch of statisticians, right, who can do mean, median, mode, and central tendency. And I came up from that background, and sure, we can get on Excel or SPSS and crank out some important things. But let me tell you what's happening in Fairfax County right now with a number of NGOs, very wealthy folks who have great companies, startups, or in established companies. And this is how they're bringing data to our children in the schools. Not in the schools. This is not happening in the schools. It's happening outside of the schools. I don't know if this could happen in the schools, frankly. So there's a little startup that meets out at Tyson's Corner in the Microsoft shop there, ages 8 to 18. And the first thing they do is they start teaching the kids about the cloud. Very basic. Here's how the cloud works. Then they teach them about how to frame a data model and do some problem framing with your data. An example would be, let's put all of the data of Fairfax County, all the business data that we can find, let's scrape around. They teach them how to get data, right, and what's legal and what's not, right, because some scraping things are not approved in certain websites. And they'll teach your 8-year-old how to put all this data in a container on AWS, right? And you start to say, okay, that's cool. I got all my data now in one place. I've done some thinking about my data. I know what my problem is. And they walk you through a very specific progression. And we're talking small children here. And then they say, now you have all this data in this big giant container that's accessible to you anywhere. What would you like to do with this data? And they walk them through that step. And they say, well, I'd like to know every, this is my daughter, I'd like to know every business in Fairfax County that's owned by a woman. Oh, what a great question. So let's figure out how to ask that data, how many women are business leaders in Fairfax County? And now we're starting to talk about some scripting, right? And how to put a basic formula together to run across that data. And then before you know it, after 6 weeks, we've got a child that can do some basic scripting in Python, that understands the nature of a data model, that understands how the cloud works, and they're now starting to scrape together all kinds of open source code that I had no idea even existed, and they're applying it against large holdings of data that they've personally gone out and collected and put in a store inside of AWS. Now, I don't know about you, but that's not really that complicated, right? If we're able to transmit this to our children. And we know that a lot of these algorithms, of course, are open source, and so they learn about the various open source communities and how you grab these already compiled elements of code or scripts, how you do calls out to different forums and whatever so that you can use their compute or whatever. I believe in our workforce. They can do this, right? It's just a matter of let's give them a class, right? And let's show them. Now, certainly, as Mr. Wiley mentions, there's going to be the sort of like you have at Google, right, where you have the engineer who's almost like a god, right, and he walks around in any clothes he wants, and he comes to work any time he wants, gets paid an NFL salary, right, and everyone worships him. We will have them, and they will help us.
I will never be that guy.
Right. We all aspire to be that person, though, privately. I know that. But they will help us get through this. But I have great belief that our workforce will be able to get here. We will have a certain number of our military analysts that are ops research background and data scientists because we make them at the Naval Postgraduate School and at AFIT. And we will be able to benefit from their expertise. But this has got to be a commodity. We're early days. Knee-jerk reaction is we need every third person needs to have a master's or a PhD in statistics and be an expert Python coder or whatever. Look, we're never going to get that. I mean, we could try. We could certainly try to get that. But at the end of the day, we've got to make these skills usable by everyone. Going back to my video game experience at Shakey's Pizza, Manhattan Beach, insert coin, avoid Klingons, right? That's where we got to get to. And it just takes a little bit of design work to construct that. And once we get serious about it and we get our senior leadership aware at really how not complicated this is, and we sort of remove the magic and mysticism that seems to surround this space, I think we're going to move pretty quickly. In fact, I know we're already moving very quickly. As sort of these tools become commodities, as the training of it becomes more and more understood, and as we understand it better. So I'm very optimistic that we will not need to buy an entire army of master's and PhD level data scientists.
Yeah. Furthermore, even if we did, under the government structure, if I'm in the civil service, when I bring somebody in the civil service, I expect, or at least I have to plan for them to have a 20 or 30-year career in the civil service. Now, given the speed at which technology changes, where processes change, even if this person had exactly the skills we were looking for, was that godlike person, I doubt they'd be that godlike person in years few. So the civil service model isn't necessarily really good for bringing in highly skilled people with very current skills. So again, I mean, it's as Colonel Kukor said, insert coin, avoid Klingons. That's where we have to get to for the analytic workforce, and it is. I completely agree. It is possible.
Yeah, I love the discussion about, and I love that you have an ops research background, and a lot of times inside the Beltway, there's we've tried this before, and I'll share with you a funny story. My daughter came in took a picture. She said, "Dad, you need to see this. This is great." She took a picture and out spit this little piece of paper where the picture came to life. She's like, "Isn't this great? You shake it and you can see the picture." And I said, "It's called a Polaroid, honey." "Oh, no, this is great, Dad. You got to see this," right? So what's old is new again. And what kills a lot of the initiatives in the data side is that, oh, we've tried that before. And I love that at the OUSDI level, they're kind of opening the door back up and saying, you know what, it's a different world today. We've got more processing power. We've got better compute resources. We're looking at the data quality issues, all those things that prevented the analytics from working in the past. So now with data integration, we can do that better. And so Colonel, it would be interesting, you know, you are looking at things at the algorithmic level, and when we lumply, and I'll call it ignorantly on my end, call artificial intelligence both computer vision algorithms, machine learning, and I understand they're not exactly the same thing, but there's been a real shortage of investment in that area for a lot of good reasons that have now become obsolete, you know, with the focus that we have. So could you talk a little bit about, from your side on the data integration, the investment in the algorithms and where you see that headed?
Yeah, so all of this is of course available online. If you want to get the sort of whole program, which I won't be able to, in the time allotted, go through, Lieutenant General Shanahan at GeoInt 2017 had a 30-minute presentation on this with 30 minutes of question and answer. And then there are documents that have been released to the public, just because this is going to be a public-private partnership, right? The government will rely on our wonderful tech base in this country to move us along at a rapid speed. But let's just think about this for a minute. Where we are right now is a seminal moment in time, right? I know this is repeated and everyone says that, but frankly, there are really some very interesting things that have come together. First, we call it the 3 legs of our stool. The first leg is the data labeling that's happening on a massive scale in industry. That's one thing that's plagued the government, which is we've not had large inventories of data that was prepared and labeled. And so our research base, struggling with hundreds of labeled, or even up to 10,000, was never able to move the ball very far. So Maven will fix that. We will use our workforce, our military and civilian analysts, and we will label data. Now, God knows we'll never get to the trillions of labeled objects that Google and Facebook and others deal with because of the massive data stores that they have that allows them to do absolutely phenomenal work. But we will get as close as we can, and we are investing in that, and that's a key part of the project. The second major piece is the compute, right? The computational infrastructure, which mostly are these GPUs, right? I know IBM has a neuromorphic approach, and Google has announced over the last few months their TPUs. But that is the computational engine for the algorithms and their training and inference. So both sides. One is the training of the algorithm, and the other is the inference at inference time when the machine needs to make the correlation or the prediction. And then finally, third is the sophisticated algorithms that are coming out of academia all over the world. There's a great open source community. Breakthroughs are published. They think there's hundreds of, if not thousands of papers published monthly on breakthroughs. And there's just an enormous amount of investment, largely from industry, but all kinds of academic interest. And the salaries are just off the chart. Right? I mean, entire university professorships at all the major universities have at least half of their staff working for the big 5 internet companies, right, on sabbaticals. And then they return, and then they go back. This space is just, I mean, you cannot get a college graduate to do anything but join those big 5 because they're all locked up and they're all getting paid a ton of money. Those 3 things have come together now and made this a remarkable time. And so it's been going on for about 3 years. I know there was a little shock on Friday with the valuation of a lot of companies in Silicon Valley. I think that's largely a little bit of correction or whatever, but certainly anyone you talk to, if they ask you why this sort of social media bubble has not popped, because friending, liking, and posting, certainly its valuation is probably, you know, check in the box, right? It's because of what's happened with automation, right? And in terms of the massive virtual war that's happening within the Valley now. And now it's government's time to sort of put its gaze there and say, okay, now how do we understand this space? And frankly, I'm one of those that may be just a little bit, you know, off, and I know this is being recorded and will be saved, and it'll probably curse me for the rest of my life. But I'm happy to tell you that this is as big as the introduction of nuclear weapons into the Department of Defense, right? What we're going to watch now unfold across all of our analytic enterprise to include medicine, operations, logistics, as we bring these technologies to bear, will change just about everything. And hopefully we will begin to do things at the super high cognitive level that we've always wanted to. We spent a lot of time searching and looking and screening our data, and then we always get to that last mile. We got 5 minutes to write the report or do the analysis. With these machines, we are hoping that we will get more time for thinking and expand into areas that we've never been able to. And of course, we're compelled to what the future is going to hold for us, which is an environment where, frankly, we're going to be facing peer or near-peer adversaries that are going to bring their AI game just as we are. And this may actually become an interesting place where the first moves are going to be entirely machine moves. And we want to, of course, be prepared for that as a nation. So as we watch and follow, the department is committed. You'll see the remarks that have come out of the front office. You'll see that we are in this game. And how this is going to change the way we do analysis, we're not sure. No one is talking reductions of personnel. What we're talking about more fundamentally is the augmentation of our high-quality workforce that will only make them better. There's only more data coming in. We can't deal with this information tsunami without automation. We got a great workforce. It's outstanding. It's only getting better as we invest more in it. And as we bring these techniques, especially these models, these automated models, these deep learning, whatever the span of algorithms, from the traditional kinetic rules-based stuff all the way to these new sort of convolutional nets that have really taken off since 2013, and the work done in Toronto with Jeff Hinson and team, we'll watch that, but they're all available to us. We see them all as part of our portfolio. And this is just an exciting time to watch how we're going to evolve and adapt and adjust. But the key thing are those three elements of the stool. We need the compute, right? We need the labeled data sets. And we need our best in industry and academia to bring us the science that will allow us to bring these algorithms to our data to see, hopefully, what will become a stunning era in terms of understanding our problems in the world itself.
So let's just say if we put all this together and we fix the data quality issues, we improve the veracity of the content, we focus then on making sure the analytics work. So as someone who, in industry who builds advanced analytics, machine learning, one of the interesting aspects is going to be when we talk about all source analysts. Naively, if you're not a military person, you think it's like CSI. You know, you search on something, there's the bad guy, let's go kick open the door. It doesn't really work that way, correct? And so
No.
let's assume you know we've got the right guy at
It's way more
OUSDI.
fun on TV.
Yeah, that's right. So if we do all of this, what do we have to do as an industry? What do we have to do as a community to get to the point where an analyst, if the algorithms predict, if the algorithms do everything as promised, what has to change for an analyst to say, okay, the machine came back and said this is the target or this is the bad person, and now we trust it, right? So
Right.
Is that a problem?
A problem, no. It's a challenge, yes. So we partner very closely with USDI in algorithmic analysis. So we use a lot of, increasingly we use algorithmic-based analysis to build out the comprehensiveness of our foundational intelligence and to provide insight from data at scale that we wouldn't otherwise have it. So, and everything my USDI colleague said about the necessity of doing that and how we have to go forward is absolutely right. So it's important, though, to have this accepted culturally and to have this be valid as an intelligence output. it's necessary to remember what the value proposition of an intelligence assessment is. And I don't care how that assessment was generated. But the ethic of the intelligence profession, and then the tradecraft of the intelligence profession makes that ethic real in an assessment, is that we are transparent and we are very clear about the level of confidence we have in our judgments, about the quality of our sourcing, and our sense of what our sourcing is and what its capabilities and limitations are, the assumptions we have had to make in order to make that assessment work, and whatever other frog DNA we've put into it in order to make it valuable and useful to the consumer. And so going forward in a computationally derived piece of analysis or source, we have to make sure that we preserve those essential elements of tradecraft. Because if I don't have those essential elements, it's not an intelligence assessment. It's something else. It's an opinion. It might be the machine's opinion, but it's still an opinion. So from the analytic perspective, the importance as we go forward is for the analysts to understand how to capture those essential elements of tradecraft in a new way of generating output. So, and what you eventually will get, I think, is machine-generated advice. You might not get a machine-generated answer. Now, I mean, some people, and again, people will disagree with me, but you won't get data in, bad guy out. I think in most circumstances, particularly for complicated analysis where you're dealing with fragmentary information, information, data lacunae, manipulated information, you will, in most cases for complicated problems, you will need ultimately an accountable human on this thing. For fact of activity, if then this, then yes, then possibly less so. But I think ultimately you have to keep the tradecraft in the assessment. And a lot of our challenge going forward is to try to understand this algorithmic generated advice, and then how to bring that into the basic tradecraft of the intelligence world. It is doable, but work needs to be done on the proper way to do it.
Correct. Thank you. So we have a few minutes left, and what I want to do is open up for a few questions. We have time, we'll have a microphone come over to, so if you can just raise your hand, we'll get a few questions in.
Hi, Mark Pomerleau with C4 ISR Net. Colonel in DebSec's memo establishing the cross-functional team, he kind of noted that the goal was to create actionable intelligence from all this FMV. Can you maybe provide some details in terms of what that means in practical terms?
Yeah, sure. So obviously, in the memo, it spoke specifically about pursuing GeoInt, right, full motion video, which we think is the best use case to start with, because computer vision, especially with all the money that's come in from autonomous cars and all the big internet companies, Facebook is challenged with this in terms of screening illicit content off of its pages. And then we've seen the murders that have occurred on Facebook Live. So they've just been, as you've seen, Mark Zuckerberg has announced how he's going to solve this. He cringed at having to hire 3,000 pet people, exploiters, right, to ped Facebook Live. So
Welcome to the party.
Right, exactly. It did bring a small sign of gratification that other people suffer the same problems we do, right? Which is no different than the analyst back in Walmart who's studying, 25 CCTV screens, right? One person trying to make sense out of multiple things. So we're going to start in a graduated approach. You would have seen in there the idea of 3 sprints, right? So the first place that we're going to start with is detection, classification, alerting, and then moving into map display. And what that'll do is it'll provide detections will simply put the bounding boxes around the objects that the CV and other algorithms identify. The classification will give those things names on a probability scale or a confidence scale. The alerting will allow the analyst who is overburdened or looking at a screen where there are literally hundreds of objects that are very disorienting to a human analyst where he has to literally find a needle in a haystack with the camera jiggering around and all the resolution issues, will allow him to put in I would like to have the computer tell me when it spots this. Let's say it's a white high-ace truck, right, which is the number one thing that we seem to be chasing around Mosul these days, right? So, but he's having difficulty finding that because the way the thing is maybe jostling around, or just the number of pure objects of the scene. And this is the thing that plagues us, is, as with anything, is the technology, as we move from SD to HD to 4K, there's just more things to see, right? The image quality is that much better. That places an immense demand on our analysts, right? So it's great to have new technology, but if you still only have the same set of old eyes staring at the screen, right, it just gets complicated. So that's the first sprint, right? And then we have a set of performance goals for the second and third sprint. We're all waiting with bated breath. As you know, CVPR, which is the big conference that the computer vision community, it goes in the week of the 20th of July, and huge focus is this thing called ActivityNet, which is activity recognition and streaming video. And we got our fingers crossed that by the fall there'll be massive breakthroughs there, which is essentially tracking objects and the machine saying this is what it means. So imagine 3 guys out in the middle of nowhere digging a hole. The activity is they're placing an IED, right? And when we have massive data coming in at us where an entire city is being imaged, imagine if we could find the 9 people that are digging holes during that, we could just go right to it without having to look at every pixel to get to that conclusion. So that's the goal, is we'll move, and our plan is as we move through these sprints, we're going to do achievable things that have already been demonstrated in industry. This is not a moonshot, right? This is not, let's spend 20 years at DARPA to figure this out. DARPA already invested in this 20 years ago, right? So we literally will take what is commercially available, we will put it in our programs of record, and we will be satisfied with the 70 to 80% solution that we will get from that. But we will move forward, and that will require the labeling of data, the procurement of the compute, and then of course the relationship with industry as we bring in best minds to solve and bring forward the algorithms that can play in the compute and in our labeled data sets. Does that help with answer your question? Thank you.
Thank you. Let's try to get one more question in if we can. Any additional questions? Yes, sir.
Tom Dickinson, retired DOD. Colonel Kukor, follow up on your question about the quality workforce. Do you have any insights into what the military academies are doing to prepare and to train the future officer corps for this kind of thing?
What a great question. So let me tell you about this workforce before I go to your officer question. Because as you know, the majority of analytic work in the department is done by our enlisted personnel, right? Our relationship with our enlisted personnel is a very close one. And as a Marine that served in multiple fusion centers leading the analytic workforce, I was turning to young Marines, soldiers, sailors, who many of them just had a high school sort of academic background, many of them with more advanced degrees than I had. And that's the workforce that does analysis, at least within the services. And they're smart, and they're just a real privilege to lead and serve with. Getting them up to speed on this is going to be critical, so I just want to give you a little bit of insight. There are a number of Facebook forums where they all come together, right? Self-organizing groups. Air Force has a number of them, and so do the other services. And what's fascinating is we're often asked this question: what do they say about this? Because the natural assumption is that the workforce is afraid that their jobs are going to be made redundant. I just want to let you know that fear is not coming from any of the analysts. There's no fear of redundancy. If I could instill fear in anyone, it would be our research community, right? Not the analysts. The research community that has largely maybe missed the boat on this, right? I'm talking within the department, right? Not industry. So they're the ones that should be fearful, right? Because this is completely overwhelming them. And, but our analysts are ready for the augmentation. They are ready to go down this road. They are already, in many cases, running these algorithms on their home computers and asking why this is not in their program of record. And so these are young people who are coding back in their basements when they come off of work or in the barracks, wherever they're at. And the demand signal from them is just overwhelmingly, you cannot go fast enough. And by the way, and this is the same sentence, make sure you give us the best minds on the planet to solve this problem. So that's just just a little sense of what the workforce, at least on the military side. Now, clearly, when you mention the word machine learning or deep learning or automation, you have various groups that have a basic understanding of what you're talking about. And then there are groups that have no clue what you're saying. So our first thought is, especially our senior leaders, we probably need some kind of professional military moment, right, where we bring them in and just say, let's just stop for a minute and take a day and walk through what does this space portend. Let's go through some definitional terms, which are going to be hard to get to because, as you know, each of these terms has various definitions that there's not really solidified on, but let's just agree on these common ways and ways to think about it so that our senior officers will know how to deal with those young E5s and E4s who are living this and demanding it. Then let's move to our junior officers and their preparation, the ROTC programs and the naval and our academies. So we've been working really hard to bring cyber to bear, right? So each of the academies now has these cyber centers. I think we've all seen a lot of investment made there. But more fundamentally, again, I'll get back to the knee jerk, right? Cyber. Okay, what does that mean? Does that mean coding? Does that mean understanding the nefarious actors out there? Is that an intelligence brief? We are settling on a space that isn't just the domain of computer science majors, right? So certainly there needs to be computer science majors. We need more STEM people. Got it, right? People have to have a basic foundation in numeracy, right? And that needs a basic foundation in engineering, right? But at the end of the day, what should that training be? I believe our first was create cyber centers, and that's probably an important path. But I would imagine in 10, 15 years, as we insert coin and kill Klingons or whatever, we're going to get to a place where this is just a fundamental, just like I explained that's happening out of Tyson's Corner at the Microsoft store. Small children, some may be STEM interested, others may be just humanities or social science, are getting an appreciation of what data is, how it needs to be shared and exposed, what the cloud is, how you build data models, how you problem frame, how you think about your data, and then how you bring small scripts together and other kinds of applications, whether they're algorithms or not, to go against that data to derive insights, like my daughter asked. I want to know every woman-owned business in Fairfax so I can get a sense of whatever. What a great question. And she can get that answer because she's been taught very basic rudimentary things. Certainly at the academies, we want to go deeper. Certainly in our professional military education, just as we went down language, we'll need to be looking at the technology aspects. But let's just be bottom line here. The nature of war has not changed, right? It's still violent. It's still hideous. It's still subject to chance. But certainly the character is changing, and that's going to demand a technology look. How technological that is, right, in terms of how deep do you need to get, that's going to be the thing we're going to be understanding in the coming months. I don't know if that gives you the perfect answer. I can't tell you right now how many people understand machine learning and deep learning in the department, but my sense is it's kind of like when the Brits started World War II, and there were literally 7 imagery interpreters in the Royal Air Force. My sense is if we were to tally everybody up who had an understanding of what this is, we would end up with a very small number. We aim to change that.
So we're out of time, but I want to thank both panelists, and we appreciate your insights. We appreciate you taking the time to do this. I know it's a busy time of year, so thank you very much.